Good day, everyone. Today we are having a look at the Moivre's theorems for mathematics level 4. So it's a very simple theorem with only three of the theorem discovered by the mathematician Moivre, who says your complex numbers must always be in polar form. So Z1 being R1 is theta 1 is just like Z1 being R1 cos theta 1 plus I sin theta 1. So that's just a short form of writing that. And Z2, and now the theorems are stated like that. So if you're multiplying the 2, you get R1 times R2, it gives you that. You get R1 times R2, then this is theta 1 plus theta 2. Then if you're doing division, you get R1 divided by R2, as you see, theta 1 minus theta 2. Then the exponential one, you raise your R1 to the power n, theta 1 times n. So let's work with these simple exercises. I call them simple because our complex number is already in polar form. If we wanted to make it complicated, we'll bring in the standard form. So this is our first exercise, which is pretty simple and straightforward. So I get 2, 6, 24,5, all this to the power 4. So if I have to simplify this using the Moivre's theorems, I realize that the numerator has multiplication. So multiplication means I'm applying the first theorem, or I'm multiplying the 2. I must apply that. My R1 is 5, R2 is 6, theta 1 is 75, theta 2 is 85. So if I apply the first theorem there, I'll be taking 5 times 6, 75 plus 80. So that's my numerator. The denominator, I'm applying the last theorem, the exponential one. If I'm raising the complex number in power form to a certain power, I raise my n, my r, my area is 2 to the power 4. Then I multiply my angle, 24,5 times 4. So that's how simple it is. Then you go through that and simplify. 5 times 6 is 30. Then if you add 75 to 1 to 80, that should give us 155. Since 75 plus 75 is 150. Then plus an extra 5 is 155. Then if you take 2 to the power 4, this is 16. Then if you multiply 24,5 by 4, let me use my calculator to do that. 24,5 by 4, that gives me 98. So I get 698. So up to so far, you see it's a very simple exercise, just by applying the first theorem and the last one. So where we are still left with the division theorem to divide two complex numbers in polar form, where R1 becomes 30, R2 is 16. So we'll just take our time, we'll take 30 over 16, then we'll take 6155 minus 98. So that is theta 1 minus theta 2. So we'll now check what is 30 over 16. 30 divided by 16 gives us 1,875. 1,875. Then if you subtract 155 minus 98, we are left with 57. So this is how simple it is. And you see your answer in polar form. So your answer is there in polar form. So if you were told to use the Moivre's theorem to simplify this, if you answer in polar form, that's brilliant. But in case they decided to go one step further to say, leave the answer in standard form, all you need to do is express this one out and then use your calculator. You can do that. So I already told you this means C stands for cos, S stands for sine, then the idea to represent the imaginary part of the complex number. So if I'm expressing this one out completely, this should be 1,875 cos 57 plus I into 1,875 sine 57. So with this, you can take your time in the calculator, you work it out. If you take 1,875 cos 57, in 3 decimal places, I get 1,023 This one is the rectangular form, or what we also call the standard form. So I've succeeded to use the Moivre's theorem to simplify this with my answer in polar form or in rectangular form. So that's how simple it is. There is also a shorter way of moving from polar form to rectangular form by just using your calculator. For those who are good with calculators, especially the Casio, I could move from here to there without this middle step. So in my calculator, I'll just click shift. Since I'm going to rectangular form, I'll touch the negative sign. I see my REC in the calculator. Then I enter 1,875. I go to shift again, bracket close. Then create a comma. Then I enter my angle, which is 57. I close bracket equal to. So I see my x as 1,021 and my y as 1,572. So the steps I've explained here for you to move from polar form to rectangular form with the Casio calculator. I said you take shift first. That's the first button you touch. Then from there you go to negative sign. Yeah. Negative sign on your calculator. You know how the negative sign is written on that. Then you enter the first number, which is 1,875. Then you go back to shift. So shift. Then from shift you take bracket close. There is a button just above the 9 button written like that. I call it bracket close. Then now from that you then enter the last number, which is 57, the argument. Then you close bracket again. Then equal to. You see how it. So it takes you from here to there. So that's the short way of doing it for those who don't have to go through this procedure. So those who are good with their Casio calculator, this one is for Casio. You can do that. I'm not so sure with other calculators. They have the same technique. So that is it for the first one, guys. Let's look at the second. So the second problem, again for me, even though it looks bulky, but it's still very easy because all the complex numbers are in polar form. So 8 force is negative 40 divided by 8 is 150. So that is what I see. All this raised to the power 3, then multiply by, you get 10 is 220 divided by 4 is 40. I guess that's what I'm seeing. All this to the power negative 2. So that is it. No matter how bulky it looks, as long as you are applying the Moivre's theorems and your complex numbers are in polar form, this is so simple. So all you need to do is take the time and interpret what is happening here. So when I look at this, I see that both complex numbers here, they are having exponents, which means I will need the third theorem there. But inside there, I'm seeing division, so I need the second theorem. So if I look at the first one, this I will reduce this with the second theorem. When I'm dividing Z1 by Z2, I must take R1 over R2. So my R1 here is 4, R2 is 8. So I will take 4 over 8, 6. Then I take negative 40 minus 150. So that is it. That is what I have to the power 3. So I've applied the second theorem there. The theta 1 minus theta 2. Then multiply by, I do the same thing here. I get 10 over 4. Then 6. 220 minus 40. So this now should be to the power negative 2. So that's how simple it is. Then you take your time and simplify it. 4 over 2 is 8 is a half, or we can call this 0.5 if you prefer decimals. Since if we add this to, we get negative 190 degrees. Then this is to the power 3. Then we multiply by 10 over 4. I guess that is 2.5. Yeah. Then this is 220 minus 40. I guess it's 180. 220 minus 40. is 180. That's true. 180 degrees, all this to the power negative 2. So succeeded to apply theorem number 2, the division theorem, to our problem. Then we need to go to theorem number 3 for each of them because each has an exponent. So I will get 0, 5 to the exponent 3. This is negative 190 times 3. So that's my first complex. Then I multiply by 2, 5 square. This is 180 times negative 2. Oh, it's not square. It's raised to the power negative 2. The exponent here is negative 2. So I'll then simplify. What is 0, 5 times raised to the power 3 times 5 exponent 3. So okay, 0, 5 exponent 3. That gives me 1/8. That's okay. Then 6. I take negative 190 times 3. 190 times 3 gives me negative 570. So I'm multiplying this with 2, 5 exponent negative 2. So that gives us 4 on 25. Then we take 180 times negative 2 is negative 360. So you see how gradually the problem is breaking down. So at this stage, I'm left with 2 functions to multiply, 2 complex numbers to multiply. My R1 is 1/8, my R2 is 24/25, so I'll take R1 times R2, then since theta 1 is minus 570 plus theta 2, which is minus 360. So that's how my multiplication works. So I'm taking 4/25 times 1/8. So that gives me 1/50. So this is 1/50. Then if I add up the angles, I'm taking 570 plus 360. That gives me negative 930. So this is my complex number in polar form. That's like the final answer in polar form after applying the Moivre's theorem. But there is one little challenge here because as a level 4 student, we are not allowed to leave our answer with a negative argument. So we are always told to leave your answer with an argument between 0 to 360. So the simple thing you do is, if you've got an answer that is negative, you just keep on adding 360 to it until it becomes positive. So what I'm simply doing is that I'll take negative 930 in my calculator. I add the first 360. It will take me to negative 570. That is still negative. I add another 360. Then it takes me to negative 210. That is still negative. Then I add another 360 again. So you see, I keep on adding 360 until I end up with a positive answer. So as a level 4 student, you must know how to move from a negative angle to a positive angle. Any negative angle has a corresponding positive angle. We just need to keep on adding 360 and check it until we arrive at positive. So this is how easy it is to get your answer in polar form. So that's my answer in polar form. So if I were to convert this answer to rectangular form, following the steps I've narrated here, I will start by taking shift in my calculator. I'm assuming that we are using Casio calculator. I touch shift, then I go to the negative sign on the calculator. Immediately I touch the negative sign, it gives me REC in my calculator. At the end of this stage, you must get REC in your calculator to remind you that we are now moving to the rectangular form. Then you enter your R, which is your modulus. So my modulus is 1/50. So I've entered it. Then I'll go back to shift again. Then I touch bracket close. There is a button just above the 9 button with the comma, with the sign for bracket close. If I touch it, it will give me a comma. It will give me a comma after my 1/50 in my calculator. I'll get a comma like that. Then I enter my angle, which is the next thing is I enter my angle. This time my angle is 150 and not 57. I enter my 150. So if I put in my 150, then I close my bracket, and then I take equal to, it gives me my positive 0.01. So I've managed to solve that using the Moivre's theorem. I've put my answer in polar form. I've also put my answer in rectangular form if it's demanded for the rectangular or what they call standard form. So guys, I hope this helps you out. Thank you very much.